Okay, so 4.3 are doing trees and counting techniques. So first off is the multiplication rule of counting. So to find your total number of outcomes, you're going to multiply all the different outcomes for each event, and that will give you your total possible outcomes for the set. So if I look at example 9, you want to find all the different numbers that are in here. So we're looking at a nursing program, and we've got psychology, physiology, and Spanish. There are 2 sections of psychology. So we're going to take those 2 sections. We're going to multiply that by 2 sections of the A&P and then the 3 sections of Spanish 2. That will give me the total number of outcomes or the total number of schedules that she could have. When I multiply those, we have 12. So there are 12 different schedules that she could have. Now, we can actually write out all those schedules by making a tree diagram. So what we're going to do is draw a tree diagram here that's going to list out all the different possibilities. So first off, we start off with 2 sections of psych. So when we do this, I'm going to call it P1 for Psych 1, P2 for Psych 2. Now, if we take Psych 1, there are 2 options for A and P. So I'm going to call it A and P1, A and P2. Same thing for the second psych. Now the last thing we've got is Spanish 2. There are 3 options for Spanish. So I'm going to call it S1, S2, S3. So now if you count all of the ending branches from your tree, you'll see we have 3, 6, 9, 12. 12 was our total, was what we said we would have for the number of different schedules. I want you to try number 10 here. Same thing. You're looking at 3 tennis matches. So you know they have match 1 win-loss, match 2 win-loss, match 3 win-loss. So I want you to try your tree diagram. So pause this now and then come back with me. So you should have a tree diagram drawn. So I wrote this as match 1 win, match 1 loss. Match 2 win, match 2 loss. So if you want to count, you will see we have 2, 4, 6, 8 for the total number of combinations that they could have for these win-loss sequences. We could have also seen if we take 2 options for the first match, 2 for the third, or second, 2 for the third. When I multiply those, we get 8 also. Okay, factorial notation. When you have factorial notation, it is the number of different order of arrangements of n items. So for example, in example 11 it says, how many different ways can 3 objects be arranged in order? When we look at this, we've got 3 ways for the first spot to be filled. Now, if I put something in the first spot, there are only 2 objects left for the second spot. Now, if we put something in the second spot, there's only 1 option for the third. So when I multiply those 3 together, we have 6. Now, the calculator will do this factorial notation for you because the factorial notation just means you're multiplying every number from that number down to 1. So if it was like 100 factorial, you would multiply 100 times 99 times 98 times 97 all the way down to 1. So you have a lot of numbers to multiply. So your calculator does have factorial notation on it. So when you do this, we're going to type in our 3. Because whatever your biggest number is, you're going to start off with 3. Then we're going to go to our math button. Now, if you look, there is a PROB there. You want to move over to PROB. Now, number 4 is your exclamation point for your factorial. So if I hit number 4 and I hit enter, we're going to see our 3 factorial, which is 6. Now we're going to look at permutations and combinations. Those are also on our calculator. You need to make sure you write somewhere that with permutations, order matters. With combination, order doesn't matter because you've got to figure out which one to use. So if you're putting things in order, or if there's like a first place, second place, third place, that's a permutation. If you're just coming up with groups of items, so if I'm just choosing a group of 5 students, it doesn't matter who's first, second, third, fourth, fifth, then that's going to be a combination. But if we have specific spots for things, that has to be a permutation. So, for example 12, we want to compute the number of possible ordered seating arrangements for 8 people and 5 chairs. Now, we write this as the biggest number goes first, then you're going to have the P because it's a permutation, because order matters, then 5 goes second. So now we have to find this on our calculator. So I have it written down there for you on how to do it. So first you're going to write in your calculator that 8, because that's your N. That's the number that comes first. So we're going to type in 8 first. Then we're going to hit the math button. And we're going to go back over to our PROB. So I'm going to go over to my PROB, and I want number 2 because we want permutation. Now, the last thing we have to type is that last number 5. So you're saying I have 8, I want to choose 5 from it. So we would have then 6,720. Now, combinations then are when order doesn't matter, like I said. You're doing the same thing when you type it in. Instead of choosing the P1, you now want to find the C1. So for this one, we are reading 4 books from a list of 10. It does not matter what groups you read first. You just have to read the 4. So that's a combination, and it would be 10C4. Now, when you go through quizzes and tests, make sure you tell me what one you are using. So don't just give me an answer because I can't give you partial points. So actually write down 10C4 or 8P5, whatever one you're using, write that down first. So we're going to type in 10 first. We're going to hit our math button, and we're going to go over to our PROB. Now we want the C1, so we're going to choose number 3, and we have to end with 4. So we have 210 combinations there. You will not be required to find those by hand. It is fine if you just use your calculator, but you need to know how to use your calculator to do that, so make sure you're practicing those. I want you to hit pause and do A and B for me. So you should have answers for A and B. So you have to think what you're doing. So for A, we have 3 officers, president, vice president, treasurer. If you have positions, automatically that should tell you you have to use permutations. So we are going to have 12P3. So we're going to type in 12, do our math button. Probability, we want P, so number 2, and then 3. So we have 1320. Now for the next one, they are choosing 3 people from a board of directors to go on a trip to Hawaii. It does not matter who gets on that plane first, just that you're going to Hawaii. So we are going to have 12C3 for this one. So we're going to do 12, hit the math button, go over to our PROB. We want C this time, so number 3, and end it with number 3. So we have 220. Again, make sure you know when to use the P, when to use the C. P is when order matters. C is when order doesn't matter.